How you doing, everybody? Welcome to my channel. Today I'm going to try to describe the way that you can build your own CNC, the materials you might need to do so, and the things that you should avoid doing it the first time. So what is a CNC? A CNC is just a computer that controls a tool, simple as that. Why you might need a CNC? Well, in my case, I needed to make a jukebox, and this cabinet has got these intricate shapes that it was kind of very difficult to make with a manual tool. So I needed a CNC to make those cuts, and the CNC being a very expensive piece of equipment, if you buy a professional one, I started to investigate how I can build my own, even if it wasn't going to be the best. So I started to search for videos about how to make it, and I found one particular one. There was a bunch of them, but the one particular one with Dave Gatton, and he had this small machine that seemed very simple enough because it was made out of wood, and he would provide the plans to make it. Now, when I just started, I didn't know anything about it, so I thought that the CNC would have to be exactly as he designed it, right? Because I didn't know any better. I started putting it together according to what he designed, and it worked, and it got me into it. So, and then slowly I started to learn what are the things that you should actually worry about and what are the things that are not necessary. This is why you might need a CNC. If you need to cut something that is repetitive and is very precise, especially for wood, it'll be good. The main components of a CNC. So basically what we need is going to be a table, and the table should be the straighter and flatter as possible. We're going to need a gantry, we're going to need a trolley, and we need some sort of rails to allow it to move on the three axes, X, Y, and Z axis. We're going to need also some lead screws, the screws that will convert the rotary motion of the motors into linear motion, with a special kind of screw that will have anti-backslash nut. And usually those screws has got very coarse threads, so it moves, let's say, predetermined distance for every rotation. Of course, we're going to need stepper motors and a controller that will hook up to the computer, which we install some program that is called Mach 3 or Mach 4, depending on how old your computer is. After that is a CAD program to design whatever piece you're going to make and generate the G code. The Mach 3 is going to use to move the motors and the three different axes of the machine. You're going to need an old computer if you're using Mach 3. In this case, I've always been using like the HP Pavilions, very common in the year 2000 to 2008, 2010, something like that. So it really, Mach 3 doesn't require a lot of horsepower on the computer. I use aluminum angles so I can put the big groove bearings on them. That was my first choice, so I follow Dave Gatton's design. Now, if you start comparing the cost of aluminum profile and the big groove bearings with the cost on some linear rails, they're not that different in cost. I think it's better to get to the linear bearings at the beginning instead of later. Very well, now that we have the hardware out of the way, let's start talking about what drives the motors, which is the controller. The good thing about this one is a card that they put together with the cables and the power supply and the fans, the cooling fans, and a switch. So basically what this is a controller that's got the motor drivers. They cool it with a heatsink and a fan. And in this case, this one that I'm showing you here is a 3-axis controller. This one from Xylotech is 4-axis controller, depending how many motors are required on your machine. Now these controllers, if you use them, you're going to have to get into the data sheet and find out according to what the controller can drive, and then you set it on the dip switches to handle the kind of current that your motor is going to require. So this involves a little more work. So I had to do something like this with my laser engraver. It will do the same thing as the one that is already done for you. So this is both the controller and the motor drivers in one single unit. But you can buy just the controller and a single card, and then you can buy separate the motor drivers. That's up to you. There's a bunch of choices on the internet for that. Now the stepper motors depends on how heavy your gantry is. This is kind of big for the gantry that I'm gonna build here, but the bigger that you can afford, the better. They don't have to be very big. It's not necessary. These motors are pretty strong. So, and then you have to take account that they'll drive a lead screw. So the torque they have with the lead screw is quite a bit. So ordering some controllers like this one, you can see in the picture there, you know, not all the time they come pretty pristine. Sometimes they're crappy. So you have to be careful where you get your controllers, but definitely you can order them online and you can build your own enclosure for the controller and the power supply. So now these kind of controllers, there's kind of for the old kind of computers that got the parallel port on the back, you use the DB25 parallel port cable, and it hooks up to the controller and to the parallel port, and then you can program Mach 3 to it. The newer controllers are USB, so you can also configure those to your computer and you use Mach 4. But for the older computer, which is pretty convenient because those are kind of cheap, you're trying to get something going at the beginning, but this is kind of like the way to go. Now the design on CAD to create the G-code, there's a whole another chapter, so that'll be probably in subsequent videos when I'm gonna talk about that. So the important thing here is just trying to give you an idea what is required to build your own CNC. It's not very simple, but if you're really into it, you can actually do it. Once you have a CNC and discover how you can easily cut your material, then you never go back. I think you just kind of forget the jigsaw and the bandsaw and all that. Those are dangerous machines. So for small projects and big projects, CNC is a great thing to have. Now, you can afford a professional made one. You're still gonna have to learn, you know, how to operate it, but you can start probably building as soon as you get it. So my intention with this video was just to give you a general idea what you're gonna need to build your own CNC. If you got any questions or comments, please write them below on the comment section. And you like the video, please give it a thumbs up. You consider subscribing if you like this kind of content. So this is going to be all for this video. Thank you very much for watching, guys, and I will see you in my next video. Bye-bye.